This quick video demonstrates to you the principles of using an oscilloscope. I won't go into any of the advanced features, but I want you to be able to do simple things like monitor voltage, or at least measure voltage, and look at time sequencing. So what I have on the left hand side here is just a power supply, and this power supply is supplying 5 volts to me. You can see that I've connected onto the negative and the positive rails. I've not touched the earth connection. Don't be confused by the colors. Some power supplies have a green earth, but that's the earth symbol there, and then that's positive and negative. So I'm using positive and negative to supply me with 5 volts, which will be on these connectors. Then on this side I have an oscilloscope, and if you don't know what an oscilloscope is, it's essentially something that displays a measurement to you in terms of a horizontal axis, which is time, and a vertical axis, which is amplitude. And this here is my probe. This is the thing that will measure that voltage for me. So if you look at the probe, you have this negative pole. This is it's really your ground of the probe, and on this side is the positive. That's the measuring. So one thing that is important to realize about scopes immediately is this crocodile clip here is connected to earth, to the earth of this chassis. And if your chassis is connected to, if you use a 3-prong plug to connect to the voltage, your mains, then this will be connected to earth in some way. And then what this does is it gives you a potential difference. It measures voltage across this and this point here, where this is the positive and this is the negative of the measuring. So what you expect to see here is an amplitude of a signal, and then in terms of time, how that thing changes. So most of the stuff that you'll be interested in at the moment will be stationary. It will be static, something that doesn't change. And later on we'll be looking at signals that changes with time. So for now, let's quickly just look at the interface of this whole thing. If you consider this oscilloscope here, you have a knob here, very important, that sets the voltage per division. So in terms of those divisions there, this knob determines, turning this knob determines how many voltages, or how much voltage is represented by one of these blocks. So if you, let's just zoom in there quickly. If you zoom in, and let's get the focus right again. If you zoom in and you consider that there says we're working with 2 volts per division. I'm just going to try to get the focus right, just give me a second. That tells you you're working with 2 volts per division for channel 1. So you have 2 channels. If you look at the channels, that is channel A, or channel 1, and that is channel B, or channel 2. And what we have on this side then, if I change this, you can see it changed to 1 volt per division. By turning it, I can change it the other side. So what you can see is you can really zoom into a signal. And by the way, if you're wondering what we're looking at there, even though we're measuring nothing, you can see there's there's a bit of an impact there, and what you're looking at there is because this thing is floating. It's not connected to anything, it's floating, so it's detecting the AC on the mains of the power supply. It's as if this whole probe is acting like an antenna, and what you're looking at there should be more or less 50 Hertz. So let's just test that quickly, and I'll demonstrate the times per division by doing that. So if you turn this knob here, you change the time represented by each block. So I don't know if you can see that, but that there is 250 milliseconds. That tells you each block represents 250 milliseconds. So if I just zoom in a tad, and what I want to do now is advanced as well, so I'm going to trigger. What you will see is there's a trigger button here. I hope you can see that. That's a trigger button. If I look at the trigger button, I get a certain menu. If I press the trigger menu, I get a certain menu here, and now I can select, do I want to trigger by edge, or on a pulse, or by video, and I select edge. So I'm looking for an edge. Trigger just means activate. So if I look at the source, I can select what do I want to trigger on, and I'm selecting channel 1 because I'm measuring channel 1. And then you can select, do you want to look for a rising edge or a falling edge? What are you triggering on? And then you can also select, do you want to couple DC or AC? So that just means, do you want to filter the DC component out? If there's a 2 volts DC voltage on the line, do you want to take it out or not? Now we're working with DC voltages in this module, so we want to set that to DC. Actually, you can't even see that, but let me just change this quickly. You can see that they're coupling DC, and if I change it, you can see it changes to AC, and that's just going to take away the DC component. But anyway, we want that on DC. And then you can select you on high frequency rejection or off. So do you want to filter the signal? Essentially, we don't care about that. Do you want to reject noise? We don't care about that. And then the other thing that I want to set here is just your trigger level. So this tells you what is the voltage that you want an activity to be triggered at. So if I change not supported, that's not good. Let's just quickly. Yeah, there's something else you need to know. If you want to trigger, you can select between auto trigger and manual trigger. And I just want to see where you can select single or just find this quickly. There we go. The mode of this triggering is normal now. So now it's triggering. It's going to wait for your slope. It's going to wait for what you set it to. So we set it to wait for an edge. And now it's going to wait for an edge before it displays it. So if I change it back to auto, it's displaying what it can see. But I want to trigger it on a certain event. So what I do is I set it to normal, and I'm going to set the trigger level, which I should find if I change this. There you go. You can see the trigger level is 1.8 volts. So if you look at the voltage per division, I have 50 millivolts per division here. By the way, that one there is the ground level for the signal. I'm going to bring it down to there we go. That's that button there, that thing there tells you where's my trigger level at the moment. So now, because I'm triggering here, you can see very clearly the signal looks much nicer than when I do auto. Auto just shows you what you have, and this triggers. So every time that it goes through that level that I'm setting, you can see I'm triggering at 28 millivolts now. Every time it goes through it, it captures it, and then displays it for me. So let's just quickly look. Now that the signal is nice, let's stop it. So it's just stopped, and I'm just going to zoom in a tad, and I'm going to measure. What I'm going to measure is I'm going to measure the previous menu. Sorry, this is a new scope and we're not quite used to it yet. So I'm going to use the cursors, and with this cursor I'm going to measure the time between each oscillation. So cursor and X1 I'm selecting, and there we go. So what you can see now, if I do this, the difference in time between cursor 1 and cursor 2, you can see that's my two cursors there. The difference between them is 20 milliseconds, which means the frequency is 50 hertz. Oopsie, sorry. I hope you can see that. So what I have is, what I've measured here is, I have a signal, an interference of 50 hertz, which is an amplitude. Let's look at that quickly. The amplitude, it's 50 millivolts per division. So that's my zero line. Let's move the zero line down. You can see this here sets the level. So I'm moving it down. Now it's nice and lined up with that line. So the amplitude is positive 1, 2 and a half divisions. So it's 125 millivolts positive, and if you count downwards it's more or less the same. So we have a peak-to-peak signal there of 125 millivolts positive, 125 millivolts negative. So you can calculate your peak-to-peak to be 250 millivolts. That's the interference. Okay, so let's go back. If I go back to the trigger menu, and I'm going to say run here and auto. So now this thing is just measuring. What I want to do now is I want to connect onto that power supply of mine I want to connect this ground. There we go. So now I'm measuring that. You can see there's still a bit of interference, but it's a bit neater now. And if I do this, you can see there's no signal. What's going on? So now I'm connecting my power supply. I'm just going to zoom out a bit again. I'm connecting the power supply to my scope. The power supply is at 5 volts. So let's just measure what this thing is doing. You can see I don't have any signal here, so I'm assuming that it's way out. I can't see it. So I'm going to change the voltage per division to have, I'm expecting, I guess, about 2 volts per division will show it to me. There we go. So that line there tells you that my voltage that I'm measuring is 1 block away from 0, and each block is 5 volts. So let's just change that to 2 volts, measure again, it's 1, 2.5. 2.5 blocks is the voltage level that I'm measuring, which relates to 5 volts. So if I now do funny stuff like this, what you should see is the signal doing funny stuff as well. Now can you see that? Alright, the same thing. So it's very important your scope must be, your probe must be connected to the negative, your ground of your probe, and then the positive measures the voltage that you have. If I now do funny stuff, so if I just zoom out, I can now do this, and you should see the change here. Let's just zoom out. I'm changing the time. Let's make it 1 second per division. You can see it's going very slow now, and now I can do stuff like this. That offset that you see on that waveform is because the voltage level never goes below 2.8 here. If I go down a tad, you can see it goes down, and I can swirl around. By the way, just to demonstrate the purpose of that DC coupling, if I press channel 1 here and I select coupling, I can make that AC. I don't know if you can see that, but it's essentially now a wave. You can see the wave there. That means it's AC coupled. So that DC voltage that I have there doesn't even show. If I do this, there we go. It's demonstrating that. So if I select DC couple, that's ground. Ground just says you're dead. You're connected to ground. If I couple onto AC, you can see that DC voltage is back. So that's the purpose of that coupling thing, and many people get that wrong. Other things to note is you can connect both channels, A and B, and then you can display a mathematical function which adds or subtracts or whatever. This one adds here, so it adds channel 1 and channel 2. If you press this math, it gives you a red signal, and you can change its level there. But there's nothing connected to channel 2, so it won't do anything. So let's just kill it again. If you want to kill channel 1, you press channel 1, you press it again, it's gone. If you want it back, press it once, and there we go. So I hope I've covered everything. It's a very quick video, and I'm pretty sure there's more that you would like to know. But the most important things is this sets the divisions, the voltage per division. This sets your time, so it squeezes it in that direction horizontally. This squeezes it in that direction. If you think of iPad, it's more or less like doing this, and it's more or less like doing that is what this is doing. And then the other important things to understand is your trigger. The trigger is quite important. So if you choose your trigger menu, you need to select normal to trigger, or you can also select single. If you select normal there and then stop single, there's a single button. Each scope works differently, but that'll trigger only once if you press single there. However, I want to trigger many times. So you select normal, and then you need to check what is the trigger level. Does that fit into what you're doing? So for example here, the trigger level, you can see the trigger level is 1.3 volts. So if I go below 1.3 volts on this here, it should trigger. Actually, it's triggering on a rising slope. You can see it's waiting for a rising slope. So if I go above 1.3, I'm expecting it to trigger. It doesn't. I don't know why. Just select trigger menu auto and just find where I am. And then normal. Yeah. And then edge type, pulse, source, wind, slope. And I'm going to trigger on a falling edge. So I'm at a high voltage, and I'm going to, oh, you know what, actually, just going to zoom in a bit. So I'm changing my time. I'm changing it to 100 milliseconds, so it updates a bit faster. And if I drop the voltage level I'm supposed to trigger, I'm just waiting for it to detect it. Hello? Ah, should have waited for an edge. There we go. There we go, and it's triggering. So I'm triggering on an edge, on a falling edge of a signal, and you can see every time I go through that level, which is at 1.78, it will trigger. So I'm just going to maneuver around there, and I'm just going to zoom out a bit again. So I'm going to turn this to go through 1.7 a few times, and you can see, there we go, so it's triggered. If I want to trigger one single time, so I'm just going to kill this, make it normal. So I'm at 1.2, I'm expecting my trigger to happen at 1.7. My edge is, I'm triggering on edge, and I'm triggering on, let's make it a rising edge. So I'm going to go from 1.1, I'm going to go to 1.7, and at 1.7 I'm expecting this thing to trigger. I'm just going to make it a bit faster, so I'm putting this on 50 milliseconds. So as I go through 1.7 now, it triggers. There we go, it shows me the signal. Okay, and I think that's more or less all you need to know.